Dear students of Standard 9, good afternoon everyone. This is your chemistry class. Dear students, we are talking about chapter 4 periodic table. Today, in this class, we will learn some new things from this chapter. At first, the special names of elements. We know there are total 118 elements and all these elements are placed in the periodic table. There are total 18 groups and 7 periods in the periodic table, and the elements of same group have same properties. So these elements are recognized by some names. There are currently 118 known elements exhibiting many different physical and chemical properties. Among this diversity, scientists have found that a set of elements show similar properties. Many of these sets are formally recognized by the following collective names. Some are named as alkali metals, some are known as alkaline earth metals, some coin metals, some halogen group, some inert gas, and some are known as transition elements. Today we will learn about these elements. At first, alkali metals. Which elements are known as alkali metals and why they are called so? Dear students, the elements of group 1, you know there are total 7 elements in group 1: hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, where hydrogen is non-metal and other 6 elements are metal. Except hydrogen, these 6 elements are known as alkali metals. Why these elements are called so? There are 7 elements in group 1 and except hydrogen, the other 6 elements are metals. They are called alkali metals because they all are soluble into water, and after dissolving into water, they produce alkali and hydrogen gas. They all are soluble into water and after dissolving into water, they produce alkali and hydrogen gas. So they are called alkali metals because they produce alkali. For example, when sodium is dissolved into water, sodium produces sodium hydroxide and hydrogen gas. When potassium is added into water, potassium produces potassium hydroxide and hydrogen gas. Sodium hydroxide, potassium hydroxide, they are alkali. Sodium, potassium, they produce sodium hydroxide and potassium hydroxide, so they are called alkali metals. Now, our second group, alkaline earth metals. The elements of group 2 are called alkaline earth metals. The elements of group 2 are beryllium, magnesium, calcium, strontium, barium and radium. These 6 elements are called alkaline earth metal because they are found in soil, in earth, as they are various compounds like calcium carbonate, magnesium carbonate, calcium chloride, etc. And they can also produce alkali. So they are called alkaline earth metals. They are found in soil as their compounds and they also produce alkali. So they are called alkaline earth metals. For example, calcium. It belongs to group 2 and period 4. That means it is an element of group 2. So it is called alkaline earth metal because calcium is found in earth as its compound calcium carbonate, calcium chloride, calcium sulfate, and also it produces alkali, calcium hydroxide, when it is dissolved into water. So calcium is called alkaline earth metal. Like calcium, other 5 elements of group 2, they all produce alkali or base and also they are found in soil. So they are called alkaline earth metal. Now, coin metals. The elements of group 11, there are total 4 elements: copper, silver, gold and rhodium. These 4 elements, among these 4 elements, the first 3 elements, copper, silver and gold or yam, these 3 elements are called coin metals. Do you know why these elements are called coin metals? Because historical coins were made by using these elements and they were used as a means of trade and commerce. The historical coins, these were made by using these three elements from the ancient age, and these coins were used as a means of trade and commerce. So the elements of this group, or this group is called, group 11 is called coin metals. Now halogen group. Halogen group, that means group 17, where there are total 6 elements: fluorine, chlorine, bromine, iodine, astatine and tensine. These 6 elements are called halogen. Do you know what does halogen mean? Halogen means salt maker, and all these elements, they are non-metal and they produce salt when they are joined with a metal. For example, fluorine joined with sodium or potassium or calcium and produce sodium fluoride, calcium fluoride, potassium fluoride, like chlorine, sodium chloride, calcium chloride. So they produce salt by joining with a metal, and these salts are found in seawater. So the elements of group 17, they are called salt maker because salt is produced by these elements, and they are called halogen because halogen means salt maker. Now our next group, inert gas. The elements of group 18, there are total 7 elements in group 18 and they are called inert gas. The elements are helium, neon, argon, krypton, xenon, radon, oganesson, and these elements are inert in nature. You know this. And these elements are positioned in group 18 of the periodic table. So group 18 elements are called inert gas. You know why these elements are called inert gas? Because all these elements are fulfilled. Their last shell is fulfilled by 8 electrons except helium, because helium has only one shell and it is fulfilled by 2 electrons, and the first shell that can contain maximum 2 electrons, so it is also fulfilled. The atoms of other inert gas group, that means neon, argon, krypton, xenon, radon and oganesson, their last shell is fulfilled by 8 electrons, and atoms having 8 electrons are chemically stable because they have no need to release, accept or share any electron. They don't make any ion. They are chemically stable or inert. So they have no need to make any bond with other atoms. Even they are not bonded with their own atoms. So they are monoatomic, but they are gaseous. These inert gases, they are also called noble gas. Now, transition elements. The elements of group 3 to group 12. These all elements are transition elements. From group 3 to group 12. That means all D block elements. Group 3 to group 12, they are called transition elements, where there are some exceptions, example scandium and zinc of period 4. Scandium is in group 3 and zinc is in group 12 in period 4. These two are not transition element. Like scandium and zinc, there are also some elements in different period. They are not also transition element. But with some exceptions, the elements of group 3 to group 12 are called transition elements. Transition elements have some special properties. The properties are, transition elements are metal. All the transition elements are metal. They show variable valency. For example, iron is a transition element. Iron has 2 valency, 2 and 3. Copper is a transition element. Copper has 2 valency, 1 and 2. Like this. The compounds of transition elements are colorful. For example, copper is a transition element and copper sulfate, you know, copper sulfate is blue in color. Ferrous sulfate, iron is a transition element and its compound ferrous sulfate, it is green in color. Like this, the compounds of transition elements are colorful. Transition elements are used as catalyst. Catalyst, this is a new term for you. Catalyst is a special type of element or compound that is used in the reaction to increase or decrease the rate of reaction. You will learn it in some next class, in next classes, but not now. Just you know the word, that is catalyst. You should know this word, catalyst. These catalyst transition elements are used as catalyst. For example, iron, nickel, they are used as catalyst. Now, advantages of the periodic table. Periodic table has a great advantage in chemistry. Now we will learn about the advantages of this periodic table. At first, simplifying study of chemistry. We know that a total of 118 elements have been identified till 2016. If we consider only 4 physical properties, there are not only 4 physical properties, there are many properties, physical and chemical properties, but if we consider only 4 physical properties, that means melting point, boiling point, density and state of matter, and also 4 chemical properties like reaction with oxygen, water, acid and alkali. That means there are total 8 properties. If we consider this, then total 118 elements. How many properties are there? 118 into 8, that comes 944 properties in total for 118 elements. It is, can you imagine? How can you remember these 944 properties for these elements? It is impossible to remember all this information. The periodic table has simplified that task. That means you have no need to remember 944 properties, because you know the elements of the same group exhibit similar properties. That means if you know the property of lithium, you can tell the properties of other 5 elements of group 1. If you know the property of chlorine, you can tell the properties of other 5 elements of group 17, like this. If we know the common properties belonging to each group in the table, we will also be aware of the common properties of all these elements. Again, since we will be familiar with the common properties of elements, we will also know the properties of compounds made with them. For example, if you know the property of chlorine, then you will know the property of sodium chloride also. And if you know the property of sodium chloride, you can tell the property of sodium bromide, sodium iodide or sodium fluoride. So, periodic table simplified the study of chemistry. Now, second point, detection of new elements. There were some blank cells in the periodic table even some decades ago. Now there are total 118 elements, but at first when the periodic table was invented, there were not 118 elements. There were some blank cells. The periodic table gave us pure idea about the elements that will be accommodating those cells and their properties even before they were detected. But we know the property of one element from this one element of this group, so we know the properties of the elements which were not detected then. But the properties of this element is same as the property of other elements of this group. You have already known that Mendeleev had mentioned about 4 elements in his periodic table which were later detected. In research, the periodic table has a large contribution in the field of research too. Suppose a scientist is interested to invent a new matter to meet up a specific purpose. In that case, he must have some conception about what the properties would be of the new matter and what kind of elements will be able to produce the new matter. He will get this idea from the periodic table, because from the periodic table, he get the idea of the properties of this matter, and by using this element, he can easily create a new matter. You will gradually come to know about the other advantages of the periodic table. Now, similar properties of the elements of same group. You know, the properties of the elements of same group are similar. Just one example will be shown here. we know the elements of same group exhibit similar properties. The elements of group 17, that means fluorine, chlorine, bromine and iodine, all are diatomic. Okay, we know gaseous molecules are diatomic. Fluorine and chlorine are gaseous, but bromine, it is liquid, and iodine, it is solid. But they belong to group 17. All they belong to group 17. So all they are diatomic. And all they react with hydrogen and produce hydrogen fluoride gas, hydrogen chloride gas, hydrogen bromide gas and hydrogen iodide gases respectively. For example, when fluorine reacts with hydrogen, it produces hydrogen fluoride gas. When chlorine reacts with hydrogen, it produces hydrogen chloride gas. And in the same way, bromine and iodine produce with hydrogen, hydrogen bromide gas and hydrogen iodide gas. Now, when these gases are dissolved into water, all they produce hydrohalic acids. For example, when hydrogen fluoride gas is dissolved into water, it produces hydrofluoric acid. In the same way, hydrogen chloride gas produces hydrochloric acid, hydrogen bromide gas produces hydrobromic acid, and hydrogen iodide gas produces hydroiodic acid. All they produce acid with water. And also all these acids react with any carbonate or bicarbonate compound and produce carbon dioxide gas. Look here, hydrogen fluoride, hydrofluoric gas, it produces carbon dioxide gas with calcium carbonate. When hydrofluoric acid reacts with calcium carbonate, carbonate compound, it produces calcium fluoride, carbon dioxide gas and water. In the same way, when hydrochloric acid reacts with any carbonate compound, it may be calcium carbonate or magnesium carbonate or sodium carbonate, it produces also carbon dioxide gas. It produces magnesium chloride, carbon dioxide and water. In the same way, hydrobromic acid and hydroiodic acid also produce carbon dioxide gas with carbonate compound. All these reactions prove that the elements of group 17 show the similar properties. Not only this, here calcium and magnesium belong to group 2. Here the carbonate of calcium and magnesium both produce carbon dioxide gas with acid. So calcium and magnesium also show similar properties. Now, test of carbon dioxide gas. In any way you can produce carbon dioxide gas. Carbon dioxide gas, you cannot see it because it is colorless gas, it is odorless gas, but you can taste carbon dioxide gas. How can you taste the produced gas is carbon dioxide or not? We know when acids react with any carbonate salt, they produce carbon dioxide gas. Like calcium carbonate, when reacts with hydrochloric acid, it produces calcium chloride, carbon dioxide and water. When sodium carbonate reacts with hydrochloric acid, they also produce sodium chloride, carbon dioxide gas and water. Now we have to taste that the produced gas is carbon dioxide or not. How will we taste it? At first, carbon dioxide is a colorless and odorless gas. If we hold a lighted matchstick inside the gas jar of carbon dioxide, it will be extinguished. Why? Because carbon dioxide gas is a extinguisher. It proves that carbon dioxide is a extinguisher. Now we will pass this carbon dioxide gas into lime water. That means calcium hydroxide. Then what will happen? This carbon dioxide gas reacts with lime water and they produce calcium carbonate and water. You know, calcium carbonate is insoluble into water, so lime water becomes turbid or opaque. And if you add excess amount of carbon dioxide gas in this turbid or opaque lime water, then after some time the lime water becomes clear again, because now calcium carbonate reacts with water and carbon dioxide and they produce calcium bicarbonate. And calcium bicarbonate or calcium hydrogen carbonate, it is soluble into water, so lime water becomes clear again. So it proves that the produced gas is carbon dioxide. Now, dear students, I have almost finished the class. Now I will show one experiment how lime water becomes turbid or opaque.
Experiment of detecting carbon dioxide gas using clear lime water. Calcium hydroxide, which is known as clear lime water, is used to detect the presence of carbon dioxide gas produced from the reaction of sodium carbonate or sodium bicarbonate salts. With diluted hydrochloric acid, by passing the gas through clear lime water. What do you observe? Clear lime water turns milky on passing carbon dioxide gas through it for a short time due to the formation of springly soluble calcium carbonate in water. On passing carbon dioxide gas for a longer time, the precipitate disappears, since insoluble calcium carbonate changes into soluble calcium bicarbonate.
So goodbye my dear students. Thanks to all.